Okay, now I'm gonna start introducing the overall architecture of our system. So firstly, as you can see, this is the where the client access the front end website of the system, which is through instance 0, and this is its IP address. So we exposes the 80 port to the client, and then engines will redirect the traffic to the front end files. So you'll see the map. Then all the HTTP requests sent by the front end will be redirected to a 8081 port, and that port is where our load balancer is, and this is also configured in the engines. And so it will be almost evenly distributed across the 4 instances, which has backend services running on and listening to the 8080 port. And the backend service is a Django program that is always running in the as a daemon process. And as you can also see, we have installed CouchDB backend on 4 nodes, so that we can eliminate the single point of failure. And also, it is noteworthy that on the instance 0, we have a relatively small weight as for the load balancing, because instance 0 also carries extra responsibilities, such as here, uh, it will be responsible for presenting the front-end pages, and also the load balancer, and also the cluster monitoring function. And as you can also see, all the services, including the Grafana and Prometheus, they are all running in a containers. So that way it ensures the scalability in case in the future this system is to be applied to a much larger cluster. And also now you've learned the overall situation of the system. Let's take a look at the cluster monitoring node, which is on instance 0. So what it does is we have Grafana that will present us with a very nice GUI that has the information of such data that is collected from the time series database. And what this database do is it collects data from all other instances. But how? Well, it is through this port, and uh, it will collect data from the node exporter that is running on all other nodes. So this information, they will be collected uh, constantly through the TCP connections. And also for CouchDB, we have a 4-node cluster, and instance 0 is the coordinate node. So, so because it is a coordinator, and it is important to understand that CouchDB does not distinguish master or slave nodes. So it is partitioned into 4 shards, and the coordinate node would use all the 3, you would try to communicate with all the other nodes, and they will eventually establish 3 other TCP connections through these ports, and to the 9100 port on other instances. And so this way it becomes a cluster. So coordinate node, it is aware of the how many nodes are in the cluster, and it will constantly try to establish collections if the collections are not established yet. And we have met a condition where one of the node was missing, like the connection was broken, and once we restored the the services on that node, then after like a few minutes, the cluster is restored to normal again, thanks to the CouchDB's mechanism of restoring the cluster through the TCP connections. Okay, so let's take a look at how we deploy our services and create instances automatically with the help of Ansible. So firstly, we would access the Melbourne Uni Research Cloud, and then the first thing we do is to install necessary dependencies such as OpenSDK, and then we would choose the images from the available images and register the image ID into the Ansible runtime memory. And thirdly, we would create 460 gigabytes large volumes that it will be attached to the instances. And thirdly, we would also create security groups for SSH access and also HTTP accesses. And we would also ensure that the necessary ports are also open so that our services can be run. And then we would go to the step where we create all those instances. And what we do is we use the previously registered image ID and volumes and the security groups, and we make them all the options when creating the instances. And then we register the created IP addresses to our inventory for later usage. And finally, we create the snapshots of those volumes. And one more thing that we do in this part is also adding proxies to the environment variable so that those instances can be accessed externally. So we can install many other third-party programs. And then the part where we install all the services and configure them. So all of them are running in Docker containers, which is why we would run the Docker first, and then we use Docker Compose command to set up all the other services such as CouchDB and Django, including the cluster configuration and also the engines, which is used for load balancing and also the front end presentation. So finally, we would also install the Grafana, which is also configured and installed and run in Docker containers. And also Grafana needs two other services, which is Prometheus, that is a time series databases that is a data source, and also Node Exporter, which provides the data of all the instances to the Prometheus. And that is how our services are deployed automatically. What you are seeing right now is the graphic user interface of Grafana. And as you can see, we have monitored 4 nodes, including the node itself. As you can recall, we have a relatively small weight in terms of load balancing, as this node has carried more responsibilities. So you can see there is a relatively smaller usage in terms of all computing resources such as CPU and memory, and also, of course, the load. And also, all these kind of information are very useful when troubleshooting. And if you can move the mouse to a specific time step, you would able to see the data at that given moment. And also there are disk space used and the disk IOs per device that in here you can see it has a relatively high number that is because we have a tweet harvesting program running in the backend. And also you can examine the network traffic and the number of context switches And what's even greater about this is that you can choose an even smaller time range to examine other informations. As you can see, it's spinning. Now we have a detailed presentation of all the data.